Now, the envelope trend and the envelope asymmetry trend are some other interesting synopsis trends. We will talk about the technical details, the clinical applications, and we'll go through an example. Now, I'm going to start with the total power trend, which we don't typically use, but it's a good example of how the data is managed. So if we look at the lower left-hand corner, if you imagine that is a segment of raw EEG, what we do is we break that into different epochs or different time periods. Now that could be a second, it could be a minute, it could be an hour, but we're breaking it into different time segments so that we can analyze each time segment. And with total power, what we do is we measure the area under the curve, and then we generate a little bar graph from each of those epochs. Then we stack those together, as you see on the lower right-hand corner. And so when we put those all together over a period of time, say an hour, it looks like this. So we have total power in anesthesia. So in the upper half of the image, what you're seeing are all of those bars stacked together over the period of an hour. In the lower corner, you're seeing the EEG that's associated with where that cursor is in the trend. So if you look at the early part of the trend, in the first 20 minutes, you have a fairly active EEG, a lot of power in that EEG, and as we get past 1510 to 1515 and 1520, you see that power significantly decreases. So this is the anesthesia induction, where you're going from a very active EEG to what we see out there at 1545, where our cursor is, which is a burst suppression. So we're looking at surgical anesthesia here. In this case, total power is very nice to have, very useful. However, the problem with total power is that it is subject to artifact. So what we tend to use instead to look at the EEG is the envelope trend. The envelope trend is an amplitude-based trend as well, and it looks at all the amplitudes within an epoch and does largely the same thing. So what we do is we take the amplitude values of all the waveforms within each epoch, and then we're going to rectify them, take the maximum absolute value, and then take a sliding median across the epochs. So you see that we've broken everything into epochs. Our sliding window could be a couple of epochs, it could be more epochs, but we do a sliding median and just take those median values. And what that does effectively is it gives us a useful way to identify the events like we saw before, but transient artifact essentially is diminished or ignored. And so this becomes a very helpful way for identifying rhythmic activity. Now this is an example of an envelope trend for rhythmic activity. So here we have generalized spike and wave activity, and you really don't need the trends to see that this is seizure activity. But what the trends do is they help quantify what's going on. So in this example to the right, we have the left envelope trend on top, we have the right envelope trend on the bottom, and very simply what you can do is look at that and say, well, our window is an hour, so there are approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10 seizures during each hour that we display on the screen. So that's what it's really good for. Again, it's not that you need it to find that seizure, but it's very helpful to quantify how many are occurring. Now, if you want to adjust what you're seeing on the screen in the upper right hand corner of each trend, you'll see that gear, and you can click on that and it will take you into the things that you can tweak. So for the envelope trend, that would include the frequencies. What frequencies are you interested in? You can narrow them down rather than looking at all the frequencies, and you can number that anywhere from 2 as low frequency on up. In addition, you can select whether you want a bipolar or referential montage. You can choose the electrodes. You can choose how many epochs you want to average in doing that sliding median, and importantly, you can adjust the time base. So we're going to look at the envelope asymmetry before we look at an envelope trend example. So here's the envelope asymmetry, and it is the right versus the left. So if you look at the upper trend, that is simply the envelope trend, and beneath that is the envelope asymmetry trend. So when we choose the asymmetry trend in our settings, we choose electrodes, let's say on the left side, and it populates electrodes on the right side for us so that we have a direct comparison. But what we're looking at is a comparison of left to right, and that's helpful for us to determine whether an event is lateralizing. The envelope asymmetry is equal to the difference between the left and the right divided by the maximum of the left and the right as a percentage. So if an event is all right-sided, you're going to see positive 100%. If it's all left-sided, you're going to see a negative 100%. Now here with the envelope asymmetry, the things that we can tweak, again, are the high and the low frequency that are involved in the data analysis. You could choose, again, how many epochs. These I would keep the same as the envelope trend just to be consistent. And the same thing with the electrodes that you choose and whether they're bipolar or referential, and the time base. So what we're looking at in this example is the envelope trend and the envelope asymmetry. The first trend is the left envelope trend. The next channel is the right envelope trend. And beneath that, we see the envelope asymmetry. I tend to like to create these as left and right. First thing I would do on this trend, though, is to adjust the amplitude so that we can see the full breadth of the waveforms. So we're going to adjust those, and we're going to adjust the envelope asymmetry. And what you see are clear events. So if I click on this peak, you'll see it takes me directly to a seizure. And again, that's a good part of what the envelope trend is helpful for, is identifying this activity. Now you'll also know, if we look at the envelope asymmetry down at the bottom, when I do this, you'll see that the activity tends to be slightly more right-sided in the positive numbers, whereas during that intra-ictal phase, where the activity is much more quiet, the envelope asymmetry seems to be higher amplitude on the left side. Although it's subtle, you can actually see that in the raw EEG. And those were examples of the envelope and the envelope asymmetry trend. Again, tips on trending: no single trend stands alone. You want to use multiple trend types to balance one off the other. Optimize your data by customizing it to your patient if you want to adjust electrodes or frequencies. And no one panel of trends will work for everybody. Everybody's EEG is a little bit different, so you may need to tweak it a little bit. The golden rule, of course, is the raw EEG is the gold standard. The only purpose of the trends is to help draw your attention to that raw EEG.